With these new data types in mind, strings, with some of the other pieces we've added in, let's go back and just remind ourselves about branching programs so that we can build on that to start creating iterative programs. So just to remind you, what's a branching program? It's something where I have a conditional that I test. If that test returns the Boolean value true, then I have a block of code I'm going to run. If it returns the Boolean value false, I got something different I'm going to run. And I'm going to simply take either this branch or that branch and pick up the remainder of the code. We've already seen a simple version of that with an if. To do the testing, we had comparisons, things like comparisons on ints and floats. These were simple numerical things. I will simply remind you again, the double equal checks equality, equal sign does not. And we had logical operations to put things together. With that in mind, we could start then building the simplest of the branching code, which were either if statements, which says if this condition is true, execute a set of code, an if else, which said if this condition is true, do this, otherwise do that, or the more general if else, which says if this condition is true, do this. If it's false, check to see if this condition is true, in which case do this, and keep doing that until I get through all of the if clauses, and if all of the conditions are false, pick up the else clause and do the rest of that. It's just repeating what we've done before, things that you've already seen. With that, though, I'm still stuck with things that can only flow through code once. I can take different branches to get there, but I can't go back and do something again. And let's think about where that might actually not help the way I'd like. As I said, simple branching programs just make choices. Sometimes, though, I might want to do something over and over and over again. How would I do that? Well, imagine you're writing a simple little video game. And part of that game has a character that gets lost in some woods. And I agree the graphics here aren't great, but you get the idea. I'm stuck in a set of woods. What I'd like to do is to say to the character, if you go right, you're going to get back to the same place. You're going to be stuck in the same piece of the woods. How would I write that as code? Well, you could say, gee, I could have an if statement that says, if I'm told to go right, here's a set of things I want to do. Otherwise, if I go left, I'll get out of there. Okay. But I want this to be something that if I keep going right, I keep getting stuck in the same spot. All right, you say, gee, that's easy. I could have another if statement that says, if the command is still exit right, do something. On the other hand, if I exit left, I'll get out of the woods. But I want to do that again. If I'm going right, I want to keep doing it. You can see the problem. I want to be in literally an infinite loop in this little video game that says, if I'm going right, I'm always coming back to the same spot. How would I write code to do that? Well, I could say, I'm going to assume that a character doesn't push go right more than 100 times. And I could write literally a big loop here, not a loop, sorry, a big sequence of ifs that was 100 deep. But maybe somebody's really persistent and they want to do it 1,000 times. You can see my problem. I don't want to write code when I have an indeterminate number of things that I want to do. I need a different way of controlling this, and I have that. It's called a while loop. We're going to look at it in detail, but the idea is that I'm going to say, here's a check, a condition. If it's true, I'm going to do this, and I'm going to go back around and do it again. And I'll keep looping around and around on this while until this condition is false, in which case I'll jump out and do the next kind of thing. And that says no matter how many times I go right, I'll always be in that loop until I finally go left and break out of it. So I can control the flow. Now for the first time, not just in a linear way, with something that lets me check conditions. And so the format of a while loop is very simple. There's the while expression. There's a test that's going to return a Boolean value, either true or false. And then with indentation, a set of expressions I'm going to evaluate. And the performance of this is exactly what I just described. If the condition is true, I'm going to do all the steps inside that code block. I'm going to go back up and check the condition. And I'll keep going through that loop until the condition finally comes out as false. All right, how might I use that to do something a little more interesting than trying to get out of the woods? Well, first of all, let's fix the woods. Here's a nice little piece of code that will do that for me. The first one says, input based on this prompt, an instruction, left or right. So n's going to be either the word left or word right. Notice what the while loop says. It says, if n is equal to the string right, then I'm going to execute this block of code, which simply again says, you're in the lost forest, go left or right. And notice what that while loop will now do. As long as n is equal to right, it will keep prompting me, asking for an input until I finally type in left, at which case this will be false, and I'll jump down and pick up the print statement. I can have an indeterminate number of times here. It's still always going to do the same thing. A little brain damage, but it's still going to do the right thing, and that's kind of nice. Now, let's see how we might use this then in other kinds of things. So here's a while loop, and notice what I need to do inside a while loop. I need to set up a variable outside so that I can test it and then do some pieces. And I need inside to have something that actually changes that variable. Otherwise, I'm never going to get out of the loop. And we can see what this does. If I type this in to my Python shell, I can set n equal to 0, which is done. And then I can say, while n is less than 5, colon, I'm going to print out n, and I'm going to set n to n plus 1. Cool. It just did what I'd expected. Starts out with n equal to 0. Is 0 less than 5? You bet. So it prints out n, changes n by 1, goes back around and checks again. Is 1 less than 5? You bet. And you get the idea. That pattern is something that we would use pretty regularly. That pattern is also slightly annoying, because what if I forget to set n equal to 0 before I start? I'm either going to get an error, because n isn't bound to anything, or I'm going to get a performance I don't expect because n has got some value I didn't expect. Similarly, what if I forget to increment? I set n equal to 0 and I say, well, n is less than 5, print n. Well, I'm going to print out 0 a billion times until I finally stop the machine because I haven't incremented. So it turns out there's another form that we're going to use that is much more convenient, and that's called a for loop. And the for loop has a particular syntax. It has a variable. It has the keyword in this case. And then it has something we're going to come back to in a second, but an expression. And what for does in this case is it is going to work through all of the values returned by that expression one at a time, executing the body of the code. Now, range is something that returns basically a sequence of integers starting at 0 and ending before 5. 0, 1, 2, 3, 4. It actually does something a little different we're going to talk about later in the course, but think of it for now as giving us the collection of integers 0 up through 4. And so if I go over here and type it, I say for n in range of 0 to 5, print out n, I get the same behavior. But this code's easier to see. It says for n in this sequence, do something. As we said, range gives us back, in essence, the integers 0 up through 4. We'll see some other variations on range shortly in terms of other ways in which we control it. But the for loop gives us a nice way to capture easily an iteration, a repeating of code some number of times, based on, in this case, a specific number, although I could also base it on a test. There's, just to recapture this then, the overall general format for a for. The special character in this case using range to give me out a set of numbers, and a body of code that I'm going to execute. And just to remind you again, it says each time through the loop, variable is going to take a value. The first time it starts at the smallest value in range. The next time it gets the next value, in this case for range added by 1, and so on. Now I can actually be a little more clever about range, because maybe I don't want to do every value in that range. Maybe I want to skip some of them. So in fact, I have something that says I can start at a different point than 0 if I give it 2 arguments. In this case, it'll give me the range of numbers from 7 up to but not including 10. Or I can give it 3 arguments. Start at 5, end when I get up to or past 11, but do it by 2. And in each case, I'm going to get a different range out. So let's look at what those do. If I go over here and say my sum is 0, and then I'm going to say for I in the range 7 to 10, I'm going to increment my sum by I. And then if I print out my sum, I get 7, 8, and 9 added together, which gives me out the thing I would expect to see. If I do the second one, my sum, again, starts out as 0, and for I in the range 5 to 11 by 2, this should give me 5, 7, 9, but not 11. And again, I'm going to say my sum, I'm going to increment by I. Remember, plus equal says add to my sum the value of I. And I print out my sum. I get 21 in this case. 5 plus 7 plus 9. Sounds right. So I can use range to actually give me a set of values. But the nice part about all of this is the for loop always will just run through all of those values, executing the body of the loop each time through. Now, as I'm doing these loops, it might be the case that I want to get out of one of them. I might want to stop if something is actually, for example, a condition is true. And for that, I have another special thing called a break, and does exactly what you'd expect. If I'm running through some code and I execute, or see rather, that special keyword break, it stops the execution of that loop at that point, or that code block at that point, and breaks out of it. So in this case, if I'm inside this while loop and I hit break, it will never execute that expression. It will pop out of all of this and pick up at that point. That lets me control how I want to deal with loops. For example, I might see a particular condition is true, and based on that say, I don't want to do the rest of this, and jump out of it. I could write it as an if, but the break gives me a natural way to control where I am inside of that loop. And so there's an example. I could set my sum equal to 0. I could run over that range, but I'd say in this case, if it's actually equal to 5, I can just break out. While I'm typing that in, think about what this might do. So I'm going to set my sum to 0 for I in range 5 to 11 by 2. I'm going to increment my sum by I. And then I'm going to say if my sum is equal to 5, break out. And what do you think? If I look at the value of my sum, it's just 5, which is exactly what I'd expect, because the first time around, I is going to have the value 5. I'm going to increment my sum by 1, but then this test is true, and this break pulls me out of that entire loop and stops the computation. Silly example, I agree, but it lets you see how break controls the actual processing. I'm breaking myself out of a loop when I decide I'm ready to do that. And there's the body of code it's going to break out of, which is why it stops after only the first stage. To put all of these together, here's a little summary of for and while loops. In a for loop, we know the number of times it's going to run through an iteration, although I can end it early with a break, because I've defined the range of things over which I'm going to do the work. It uses a counter that's captured inside the for loop itself. I can always rewrite a for loop as a while loop by taking that variable that I'm using, that counter I'm using, pulling it outside, initializing it, and explicitly doing the increment to the counter inside of the loop. A while loop can have an unbounded or unknown number of iterations. Again, I can always end it early with a break statement, but I here have to just set up the counter ahead of time outside of the loop, and I have to make sure I increment it inside the loop. And unfortunately, I can't always rewrite a while loop using a for loop. You'll see in most code, we tend to use for loops when we know what we're going to do as a computation. We'll use the while loop when there's going to be a condition that we can't predict that's going to allow us to break out of that loop. But both of them give us the first version of iterative algorithms.